All right, guys, it is the last day for this week. So we just took a formative yesterday, so we are going to kind of move into a new idea, kind of an extension topic. Um, so if you have any questions still about just kind of that basic unit circle, what it's used for, and those radian measures, make sure to be asking questions so that I can help you and we can keep on moving forward. So what we're going to start today is we're going to start talking about inverse trig functions. So I want to be very clear when I'm talking about inverse trig functions. I'm not talking about like cosecant, secant, and cotangent. Those are reciprocal trig functions. So those are where we're just taking the reciprocal of our values, not the inverse. We're not undoing or looking for kind of the opposite of our trig functions. So what I want to start with today is I want to start with 3, 4, and 5, where we're going to look at what value gives us these outputs. So what you're going to want to do is you're going to want to have out your unit circle next to you so that you can kind of be looking at each of these. So the first one is the sine of what equals root 2 over 2. So when I'm looking at this, I want to find when is the first time that this occurs. The first time that I have root 2 over 2 is at 45 degrees or pi over 4 radians. For the next one, the cosine of theta equals negative root 3 over 2. The first time this is going to happen is at 150 degrees or 5 pi over 6 radians. And then when is the tangent of theta equal to 1? This happens at 45 degrees or pi over 4 radians. And just as a quick reminder that these do occur more than once in our unit circle. They happen every 365 degrees, sometimes more frequently than that, like every 45 degrees, or I'm sorry, every 90 degrees or every 180 degrees. But right now we're just kind of looking at the first time that that occurs. So what I want to do on this next part is we want to talk about what's the difference between each of our trig functions and their inverse. So on the notes, it didn't end up copying this little that inverse symbol that we use. So if you guys could just draw that in on your notes, please do that. So we're wanting to talk about what's the difference between sine and inverse sine, cosine and inverse cosine, tangent and inverse tangent. So whenever I talk about the sine of something, I talk about my opposite over my hypotenuse. So I'm looking for the ratio of these two sides when I'm talking about the sine. So if I said I was looking for the sine of 45, I would be looking for that ratio. When I'm talking about the inverse sine of something, I'm looking for the angle measure. So for example, I would be having something like we had above, the sine of theta, the sine of my something equals root 2 over 2. So really, when I'm looking at my sine, I'm looking at that ratio. When I'm looking at my inverse, I'm looking for my angle. And that's going to be true for all three of these. My original trig function is looking at a ratio, and my inverse is looking for an angle. So, for example, cosine oops, cosine is adjacent over hypotenuse. So I would say the cosine of 150 is, let's see, negative root 3 over 2. But if I'm looking at my inverse cosine, I'm looking for that angle. So I would write the inverse cosine of my ratio equals my angle. So when I'm writing these inverse trig functions, I'm going to write inverse cosine of my ratio equals the degree. So in case of the sine, I would write the inverse sine of my ratio equals my degree. All right, so last one, tangent. So my tangent is my opposite over adjacent. So I would write the tangent of my angle equals opposite over adjacent, where my inverse tangent talks about my angle. I'd write the inverse tangent of opposite over adjacent equals my angle. So if I want to evaluate the following, we can do this. Let's do these top three just using our unit circle. And then the next 5 we will do with our calculator, so we learn how to do it that way. So the inverse sine of 1/2. So this, maybe in a more familiar way, would be if I wrote, I'm sorry, I don't know why it keeps doing that, the sine of theta equals 1/2. So either way would be, you're thinking about the same idea. So looking at your unit circle, we're going to find that theta equals 30 degrees or pi over 6 radians. Inverse cosine, so we're thinking the cosine of theta equals negative 1/2. So theta would be 120 degrees or 2 pi over 3. Then if we had the inverse cosine of 2, well, what I want to remember, so we're looking for the cosine of what equals 2. If you guys remember way back to the very beginning, one of the very first pages of notes we took, we said that sine and cosine are always going to have values. They're always going to be between -1 and 1. So I'm just going to put like a little important bubble around this. Our sine and our cosine are always between -1 and 1. So if these equal x. So this one here is actually, if you typed it into your calculator, you would get an error. But we're going to see there is no theta value. There's nothing that's going to get you a cosine of an angle equal to 2. All right, so number 9 and 10, we want to solve each angle to the nearest 10th of a degree. So I said we want to try these ones using our calculator because 0.6 and -2, those aren't values that we have on our unit circle. So we're going to want to try these kind of in a different way. And so what I want to do is I want to look at degrees. So that's the first thing that I want to make sure is in my calculator, I need to be in degree mode. So before we even start this, take 5 seconds and make sure your calculator is in degree mode. Okay, so first thing, I have to, if I'm looking for an angle, I'm going to convert this to my inverse cosine. The inverse cosine of 0.6 equals something. So on your calculator, what you guys are going to do is you are going to do second, and then you're going to hit your cosine button. So second cosine, this is going to give you your inverse cosine. So it should pop up with something that looks similar to what we have written here. Then you're going to put in 0.6, and you should get out approximately 53.1 degrees. Then we're going to do the same thing for the tangent. We're going to rewrite this as our inverse tangent of -2. And when we type that into our calculator, we should get approximately, if I don't keep zooming out, -63.4 degrees. All right, so the next thing that I want to do is I want to solve for the missing angle measure. So we did do this a little bit on that review page. Some of you had learned this in geometry. Some of you haven't, so I am going to kind of go through it in detail. Solving a missing angle measure when we're looking at a right triangle. So in this case, for number 11, I am given all 3 sides. So really I can do whichever trig function that I want. I just have to make sure that I'm doing it off of my theta angle. So I'm going to do cosine. I'm going to look at the inverse cosine since I'm solving for an angle. Cosine is adjacent over hypotenuse. So I'm going to type into my calculator the inverse cosine of 3/5. And I'm going to, in this case, again, I'm looking at degrees. Just because I am looking at a triangle, we want to make sure we're in degree mode still here. This is going to get me approximately 53.1 degrees. All right, number 12. Number 12, if my angle is theta, I am given my opposite and my hypotenuse. So that means I'm going to be looking at my inverse sine function of opposite over hypotenuse, which is going to get me approximately 54.34 degrees. And number 13, if this is my theta, I'm given my opposite and my adjacent. So that's going to be my tangent function. I'm going to look at my inverse tangent of 9/4, which is going to get me approximately 66.04 degrees. All right, we are going to do the next 3 together as well, but I do want to go back up here where we talked about our sine versus our inverse sine. And I do want to make one little note over here to the side. And I want to let you know that I can write this as inverse sine, or sometimes you're going to see it written as arc sine, or arc cosine, arc tangent. These are all the same when I'm talking about like the cosine versus arc cosine, tangent versus arc cotangent, or arc tangent. These are all the same things. These are equivalent. It just depends on where you're seeing it, whether they're going to use that inverse notation or the arc notation. So if you do see somewhere that it says arc tangent or arc sine, they're just saying inverse. Okay, so number 14. So I really think that you guys can do these three independently. So if you do want to pause and try these three on your own, I would really suggest that. And then I'm going to go over all three of them. So I would suggest pausing, trying all three of these on your own, and then coming back and checking your answers. Okay, so when we're doing these, let's take a look at 14. So a group of hikers plan to walk from a campground to a lake. The lake is 2 miles east and half a mile north of the campground. To the nearest degree, in what direction should the hikers head? So what I want to think about for this one is I'm going to start somewhere. This is going to be my campground. I'm going to go 2 miles east and half a mile north. And now I am at the lake. So when I'm looking, the quickest way to get there, the quickest way to get anywhere is always on a diagonal. So really what this is asking me is to find what degree do I need to make that diagonal at to make the quickest way possible. So if I'm looking for this angle here, I'm given my opposite and I'm given my adjacent. I'm going to be using the inverse tangent function. Inverse tangent of opposite over adjacent, which is 2. Well, 1/2 over 2 isn't a number, so I'm going to rewrite this. If I do 1/2 divided by 2, that's the same as doing the inverse tangent of 1/4. And if I type that into my calculator, to the nearest degree, I'm going to get that it's approximately, I want that angle to be approximately 14 degrees. Number 15, so a painter needs a 30-foot ladder leaned against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? So if I'm looking at, here's my ladder, here's the wall, and here's the ground, I'm going to have a right angle with the wall and the ground. And then I know my ladder is 30 feet. So, and then it tells me that the distance between the base of the ladder and the wall should be 1/4 the length of the ladder. So that's saying from the base of my ladder to the wall should be 1/4 the length of my ladder. So 1/4 of 30 is 7.5. So that means the base should be 7.5 feet. And then what acute angle should the ladder make with the ground? So if this is my ground and this is my ladder, I'm looking for the angle right here. So I am, from this angle, I have my hypotenuse and I have my adjacent. So I'm going to be using the inverse cosine of my adjacent over my hypotenuse. When I type that into my calculator, I get approximately 75 degrees. And thinking about it, that makes sense. When we're using ladders, we typically try to have the base of the ladder fairly close to whatever we're leaning it up against. Okay, last one for today. A road has a 5% grade, which means that there's a 5-foot rise for every 100 feet of horizontal distance covered. what is the angle of elevation that the road makes with the horizon? Round the nearest tenth of a degree. So this phrase here, angle of elevation, means that I need to start with a horizontal, and I'm looking at something that goes up. So I have an angle of elevation. This tells me that I have a 5% grade, which means for every 5 foot of a rise, I have 100 feet horizontal. So what angle of elevation, so what is this angle right here that I need to make? So if I'm looking, I'm given my opposite and I'm given my adjacent. So I'm going to be looking at my tangent. The tangent of 5 over 100, and that's going to get me approximately 2.9 degrees. And again, that makes sense because if I'm just going over 100 and up 5, that's not a very big opening. All right, guys. You guys have a little bit to work on for today, but that is it for this week. Please let me know what I can do to keep supporting you. If you guys have any suggestions or any changes that you guys want to see made, please, please, please email me. You will not hurt my feelings. I really, really liked the feedback that I got from you guys last week, so I would love to get some more. Have a good weekend, guys.